Hey guys, hope you're doing well and thanks for watching today's video. So now we've gone through the logic introduction, we've gone through some practice with logic, with using the keys, like identifying if something's true or false, but now we actually need to practice developing these statements. So what we're going to do is we're going to go through some examples where they give us one of them and we have to be able to back out the rest. So let's just get right into it. This is something a lot of people can find pretty challenging, so definitely take your time on these. I recommend you pause the video now, you try this on your own, and then you go through and see what I did. So the first one, complete the chart below and clarify which statements are true and false. Okay, so first I want to identify my P and Q. So P, as you know, is the hypothesis. I'm just going to type this in actually because I have my keyboard with me. So hypothesis. Well, in this case, that's the P, that's what comes after the P, after the if. So that's a quadrilateral is a rectangle. So a quadrilateral is a rectangle. So that's kind of our P value. That's the hypothesis. And then we're saying because that happens, our conclusion is that it has two pairs of parallel sides. Okay, that sounds good to me. And now you really need to know your shape situations. You need to know the rules for shapes. So is this true? Is this false? To know that, you're going to have to know your properties of shapes. And this is actually true. If you have a rectangle, you can kind of think about it as well. If I have a rectangle, well, it obviously has two parallel sides, two pairs of parallel sides. So this one, I'm going to put a T right next to it. It's true. Actually, that's a really bad T. Let me make this a little better. True. But now I want to develop the converse. And remember, the converse says if not P. Yeah, I mean, if Q, then P. I was getting confused between the converse and the inverse. So if Q, then P. So we need to think if Q, then P. Well, we just said that the conclusion is it has two pairs of parallel sides, and it refers to a quadrilateral. So we're going to say if a quadrilateral has two pairs of parallel sides, it is a rectangle. So that is the converse. That looks good to me. Now we need to do the inverse. Remember, let's think about what this one is. Well, it says if not P, then not Q. So now that is when we take the negative of the first statement. So if the quadrilateral is not a rectangle, if a quadrilateral is not a rectangle, then it does not have two pairs of opposite sides. Not have two pairs of parallel sides. Okay, and lastly, the contrapositive, which is kind of when we can take the converse and make them both negative. So that would be if a quadrilateral does not have two pairs of parallel sides, then it is not a rectangle. If a quadrilateral does not have two pairs of parallel sides, then it is not a rectangle. Let me add my then to this just so it's a little clearer. You don't have to have then, but it does make it a little bit easier. So now evaluating the truth of each of these. So let's think about the first one. If a quadrilateral is a rectangle, then it has two pairs of parallel sides. We said that was true because you can kind of think about the rectangle and you can picture the two pairs of parallel sides. Let me just draw one really quick and show you what I mean here. So we've got a rectangle. Sorry, it's not very good. Here's one set of parallel sides. Here's our other one. So that's true. But now it says, so if I know the statement's true, I can assume the contrapositive is true. That's our rule. And we're not going to go through and check now because we're going to assume that we know the rule so we can go pretty quick. Now the converse. If a quadrilateral has two pairs of parallel sides, then it is a rectangle. So you need to think, are all quadrilaterals that have two pairs of parallel sides rectangles? Think about that for a second. And I'm going to say that is false. Because what about my parallelogram? This is not a rectangle, but both sides are parallel. So it has two pairs of parallel sides, but they are not a rectangle. So that is false, and I know, well, the truth value of my converse and the inverse are always the same, so the inverse must be false too. So I get true, false, false, true. So that's a good first example. Now let's go on to the next one. So if x is greater than 0, then the absolute value of x is greater than 0. So again, I'm going to identify my hypothesis and conclusion. I recommend you pause and try this on your own before you watch what I do, just to get yourself some practice. So hypothesis is x is greater than 0. And we're concluding that because x is greater than 0, well, the absolute value of x is greater than 0. Okay, so converse, remember we kind of switch everything around there. So then we say if the absolute value of x is greater than 0, then x is greater than 0. So if the absolute value of x is greater than 0, then x is greater than 0. Inverse, we take the first statement, this original statement, and we make them both negative. So we say if x is not greater than 0, or we could say less than 0. I'm going to say less than 0. Then the absolute value of x is less than 0. You actually would have to say less than or equal to, because we said if x is greater than 0, then the absolute value of x is greater than 0. So less than or equal to. Or you could just say not greater. Either one works. You could really do either one. I'll say less than or equal to, because I'm just saying not greater. So you'd have to say less than or equal to. Equal to. Okay. Now lastly, the contrapositive. So the best way for me to take this personally is I look at the converse and I just make both of those negative. So if the absolute value of x is greater than 0, so if the absolute value of x is less than or equal to 0, then, and now I'm going to take the negative of that x is greater than 0, then x is less than or equal to 0. So those are my statements, and now I need to take a second and identify, well, are they true or false? So if x is greater than 0, then the absolute value of x is greater than 0. Well, that's always going to be true, because remember, absolute value of x is defined as the distance from 0. If I have a positive number, that distance from 0 is also always going to be positive. And absolute value of x, if you think about it, it can never be negative no matter what. So absolute value of x is always going to be greater than 0, making this true all the time. So the first statement is true. And remember, just like our rules say that the contrapositive must be true as well. And let's quickly just take a look at this time. If the absolute value of x is less than or equal to 0, then x is less than or equal to 0. Well, the absolute value of x can never be less than or equal to 0, so x is less than or equal to 0. Well, that would be true, because the absolute value in no situation is that false. So basically you make that true because it can never be false. So you'd never have a situation where the absolute value of x is less than or equal to 0, except at the point 0. So if the absolute value is 0, then x is equal to 0. So that's when it would be true, and that's the only situation where this would happen, making the entire statement have a value of true. It's never false. You could think about it that way. Okay, converse. If the absolute value of x is greater than 0, then x is greater than 0. Be careful with this one, because if the absolute value of x is greater than 0, well, x could be negative 10, but its absolute value would be 10, which is greater than 0. But x is not greater than 0, making this statement false. And we know the inverse must be false too, but let's figure out why. It says if x is less than or equal to 0, then the absolute value of x is less than or equal to 0. This one's actually easier to determine the truth value for than the converse, because if x is less than or equal to 0, let's plug in a number, negative 10 again. The absolute value of x, well, that would be 10. That's greater than 0, so that would be false true too. So that's our second example. And I have, I think, one more. Oh, yeah, okay, yeah, I do. All right. This is a harder example because they give us the contrapositive, and we have to be able to go back and get all of the other ones. But we want to do it the exact same way we've been doing it, where we first label the hypothesis and the conclusion. So hypothesis, sorry, it always messes up when I start typing. Let me get where I need to be. Right here. All right, hypothesis. So what is our hypothesis here? We're saying that we got to think about what the contrapositive means. remember the contrapositive is if not, sorry, I can't type this in. Contrapositive, so we have to memorize these rules. It says if not Q, then not P. So we have to use that to get us to the hypothesis and the conclusion. So if not Q, that means that if not Q is the part that says if a triangle does not have one obtuse angle. So what is the opposite? Because we don't want to have the not version, we want to have the positive version. If a triangle does not have one obtuse angle, the conclusion must be if a triangle has an obtuse angle. So the conclusion would be a triangle has an obtuse angle. I'll put has one obtuse angle instead of an. Has one obtuse angle. That is my conclusion, because if not Q is if a triangle does not have one obtuse angle, then Q must be a triangle has one obtuse angle. So that is our conclusion. The key is here realizing that that's the conclusion, not the hypothesis. Because of the way the contrapositive is ordered, it actually says if the conclusion is not true, then the hypothesis is not true. So now we need to try to get the hypothesis, and that one is, then it is not an obtuse triangle. The opposite of it, if it is not an obtuse triangle, is if a triangle is obtuse. A triangle is obtuse. Okay, so now I have the hypothesis, I have the conclusion. I want to start with the statement just because that's the easiest. It gets my mind ready to do all the rest of them. So the hypothesis is if P then Q. So I'm going to say if a triangle is obtuse, then it has one obtuse angle. So that is my statement. That's if P, then Q. So we had to identify what P and Q were first, and then we could plug it in here. Then the converse now, this is just like our other problems. So that means if Q, then P. So that's if a triangle has an obtuse angle. Oh, I said if it was one obtuse, if it has an obtuse angle. If a triangle has an obtuse angle, has one obtuse angle, I keep writing in, then it is an obtuse triangle. Because it'd be if the triangle, then the triangle is obtuse, which is the same as an obtuse triangle. Then now let's think about the inverse, which says if not P, then not Q. So if a triangle is not obtuse, then it does not have one obtuse angle. Okay, so now let's identify the truth statements of these, the truth values of these. So first statement, the original statement. If a triangle is obtuse, then it has one obtuse angle. Is that true? If a triangle is obtuse, then it has one obtuse angle. And it is. If you think about an obtuse triangle, it's got to have only one obtuse angle in it, because it can't have two, because that would be over 180 degrees total, so it's got to only have one. So that makes the contrapositive true, and we can think about the contrapositive. If a triangle does not have an obtuse angle, then it is not an obtuse triangle. And that one might even be easier to analyze, so you could have started with the contrapositive and then figured out, well, the original statement must be true because the contrapositive is true. Just another way to do it. And then we have the converse. Remember, we have to analyze the converse or the inverse, and they have the same truth values, so when we analyze one, we're good. And just to change it up, let's analyze the inverse. If a triangle is not obtuse, then it does not have one obtuse angle. Well, that's true. If you think about our other triangle types, we have acute, we have equilateral, equiangular, we have all these other things, but the only type that is obtuse are the ones with the obtuse angles. So if a triangle is not obtuse, it does not have an obtuse angle, so that is true. Then lastly, our converse would have to be true, but let's think about why. If a triangle has one obtuse angle, then it's an obtuse triangle. That's the definition of an obtuse triangle. It's got one obtuse angle in it. So again, I hope you realize and understand the logic rules now and kind of understand how to get them. They can be tough. They really can. And part of the reason they're so hard for a lot of students is you have to understand the math rules very well to use them. Like, even if you can make the contrapositive, the converse, the inverse, you then have to be able to understand, well, is this true? Is this false? And that can be hard sometimes. You really need to think, is this true in all situations? Is this ever false? And that will help you out. So Let me know if you have any questions. Thanks for watching. I hope you understand logic a little bit better now. Have a good one.